So we've already had the question, what is a polynomial? So these are polynomials. X cubed plus 4x squared plus 3x plus 7. That's a polynomial. This is a polynomial, 7x squared minus 4. These are not polynomials. X squared plus sine x. 3x cubed plus 4 over x squared. What do you think polynomials are? Go on.
The equations are like a whole number, like 7 or 4. Do you know what I mean?
I do know what you mean.
Is that right?
No. But I do know what you mean. Anybody else want to have a go? Or maybe it's easier to think, what do you think stops something being a polynomial if you look at the ones we've got? Fractions. Okay, this is a polynomial. That's a polynomial. You're on the right sort of line, particularly with this one down here. An x on the bottom. Yeah, an x on the bottom, because that's the same as 3x cubed plus 4x to the power of what? Okay, that's not a polynomial, that one. So yeah, negative indices are not polynomials. Anything with anything like sin, cos or log or anything like that is not a polynomial. So polynomials have positive, well, actually, no, I'm going to change that to non-negative, and I'll explain why in a minute. Non-negative integer powers of x. They have non-negative integer powers of x. Why did I change positive to be non-negative? Yeah, because up here, that's 7. You could think of that 7 as 7x to the power of 0. So a power of 0 on the x is absolutely fine. But they have to be non-negative. That rules out the minus 2 one over here. Integer powers, and they won't have other things in there like sin, cos, log, anything else that you haven't even met yet. Square roots, because square roots are non-integer powers. Okay? So, this one here, 2x squared plus 4x minus 5. What can you tell me is a key thing about that polynomial compared with this one? 4x cubed minus 7 plus 3x squared. What's a key difference? Maybe a key way of classifying those two. The top one's not got any cubes. So this one here, the highest power is 2 here on the x. What's the word for that one then? If somebody's got the highest power of 2, just think 2 chapters ago. Quadratics, yeah, okay. This one here, we have the highest power is 3. What's the word for that one? Cubic. What if it's power of 4? Quartic. Quartic. And then in theory you probably have quintic, I guess, but we don't really bother after that.
Quadratic if they've got a 2, because 2 is like die or die.
It's a very good question. I'm not going to answer now because I haven't got the answer at the top of my head, tip of my tongue or anything like that either. So it's a good question. I'll go away and think about that one and try and come up with an answer. So over here, this one here with the highest power is 2. That's known as having order 2. It has order 2. When this one has order 3. Sometimes instead of the word order, there's another word can be used. It has degree 2 or degree 3. But usually it will be the word order. So order or degree in relation to these is basically the highest power there is. Now I said on the board when you came in that we would look at adding these things together. Let's just look at adding those two together. If I add those two together, if I add together those two polynomials, what do you think we get? An equation. You don't get an equation. Why don't you get an equation?
X doesn't equal.
It doesn't equal anything, yeah. So what do you get? What's the word for it? Not an equation, but you'll get an expression. Yes, that's right, you'll get an expression. So, what expression would you get if you added those two together? Can anybody hazard a guess as to what you get if you add those together? Go on.
4x cubed plus 5x squared plus 4x minus 12.
Correct. Yes, well done. Okay. Basically, if this is order 3, you need an x cubed column, an x squared column, an x column, and a x to the power of nothing column. So the first one you've got is 2x squared plus 4x minus 5. The next one you've got is 4x cubed minus 7 plus 3x squared. So that's like a heading column here. And you added up column by column. There's 4x cubes. 2x squared plus 3x squared is 5x squared. That's a positive one. There's a positive 4x, and over there there's a negative 12. That is how you add polynomials. You just look at each order bit and just add all them together. Subtracting, exactly the same. Subtracting is exactly the same. So we've just dealt with adding and subtracting. Okay, so that's adding, and subtracting would be exactly the same process. So, what was the next thing it said on the board at the beginning? Can anyone remember? Timesing, multiplying, yeah. Okay. So let's start off with two simple ones. So we're going to look now at multiplying. And if we look at multiplying 3x plus 7 and 4x minus 5 together, is this something new? No. Okay. That's what we would normally write down as 3x plus 7 and 4x minus 5. Some of you will be doing that in your head. Go on.
Do these have an order? Are they order 1?
This one here would be order 1, yeah, because the highest power on any x is a 1 there, there's an x to the power of 0 there, a 1 there, x to the power of 0 there, so yeah, those are both order 1. So, if we multiply that together, can anybody tell me what they get? Anyone done that already? Go on.
12x squared plus 13x.
Which came from 28 minus 15.
And then minus 35.
Yeah. Okay, and what order is that one? Order 2, okay. Now, you can use whatever method you like to do that. You've all got methods that work for you to do that. It could be FOIL, it could be the grid method. First outsides, insides, lasts. Okay, so you do the. So if you're doing FOIL, the first thing in each bracket, that and that times together. Then you do the outside things, times those together, inside things, and then the things that are last in each one. It's just a way of making sure you get every combination in there. When I was at school, it was called FMOL, firsts, middles, outsides, and lasts. And for some reason, my maths teacher, Mr. Mortimer, I seem to remember he told me FMOL was a little man in a top hat or a bowler hat. I had never worked out why. In a parents' evening last night, open evening last night, one mum came along who I was at school with, and I thought I ought to ask her because she was in my maths class with Mr. Mortimer. I didn't. There we go.
Is it weird that people you were in school with
No, it's just quite nice actually.
teach their children?
Quite nice. Well, she may come here next year. We'll have to see. She's not here at the moment. So multiplying. Okay, that was nice and easy. Let's have a look at one which is slightly more challenging. Let's try and multiply 3x cubed plus 7x minus 12 and 4x cubed plus 12x plus 2. We all happy to do that one then? In our heads? No, that's a very sensible answer. No, if you try and do this in your head, unless you're Callum, you wouldn't do. I'm very pleased to hear it actually. It's probably not wise to try and do these in your head. So, how could we go and do that, do you think? A grid, yeah. The old-fashioned grid method. I know you don't all use it for the other stuff, but it works. So you've got 3x cubed, a positive 7x, and a negative 12. You could have along the top. And then down here, a 4x cubed, a positive 12x, and a positive 2. And you're multiplying. Yep, the grid method works on these. As big as they get it would work, but you wouldn't get one bigger than this. So have a go at completing the grid and then collecting all the terms. I'm going to pause the video here and we'll see the outcome of this in the next clip.